Now let's move on to part C of question number 2. We have part C asks us to find fz of z when z is equal to xy. So now we have w as y, and we have this j of xy equals to, it's just the derivative of f zw. So we have it here as a matrix, and we get y here. So when we do f of zw, we have f zw x1 y1 over the absolute value of j, and we have 1 over the absolute value of w times f xy of z over w, and we get 1 over absolute value of w times f x of z over w times fy of w. And now we can do fz of z, which is the double integral of f zw. So this is the double integral, and we can write this double integral as the integral from negative infinity to infinity, 1 over absolute value of w times e to the negative z over w times the unit step function of z over w times e to negative w times the unit step function of w times, dw, sorry. And the integral from 0 to infinity becomes 1 over w times e to the negative z over w plus w dw times the unit step function of c. For part D of question number 2, we are looking for fz of z when z is x over y. We have fz of z equals the integral from negative infinity to infinity, the absolute value of y times fxy dy. And the integral can be written as this, and we just do like how we did before. We kind of transform this with the unit step function, and we get the integral from 0 to infinity times the integral from 0 to infinity y e to the negative c plus 1 y dy times the unit step function of z. So the whole thing becomes 1 over z plus 1 squared times the unit step function of z.